Alright then, hello guys. Today I'm going to be doing a new Hack the Box challenge, and the Hack the Box challenge that I'm going to be doing today is going to be called Hack the Box Console. So let's get started. So with Hack the Box Console, it's a pwn challenge like usual, like the ones I'm usually doing. So the very first thing I want to do is just check just check what kind of file it is. And doing it real quick, we find out it's a 64-bit executable x86-64, and it's stripped. And what does it mean by it's stripped? That means for the most part the names of the functions aren't like originally there. They might be like worded differently or like named differently, so I guess makes it a little bit harder for us to see the actual names of the function. But anyway, that doesn't matter for the most part. So now the next spot is just checking the permissions that this file holds. So in my case, I think I have it checked. I made a check.py, which all it does is just does pwn imports elf, and then this specific function tells us the permissions that it has. But that's not the only way to do it. There's like multiple ways, but this is how I do it specifically. Other people have different ways. My way is not correct. You can use any other way. It's just how I do it. So running this tells us the certain permissions that it has. If we get no pi, basically means that any address that we find in this file are just like basically static. They're not changing. It's for the most part. It makes it easier for us, I guess, for the most part. Then we have nx enable. What does this mean? Can't execute shellcode. And no canary found. So that means there's no type of thing. Like usually if canary is found, we usually have to leak the canary so we could find because I guess canary makes it harder for us to actually use the addresses that we find inside a certain binary for the most part to be able to use them. Because it's like setting an offset of some sort. I don't know. Still kind of confusing for me. Still need to study on it, but that's how I understand it for the most part. Maybe the more CTF pwn challenges I do, the better I'll be able to explain it. And then partial real world. So anyway, let's get started. So with this challenge, for the most part, I guess we just run it to see what it does to have a quick idea. So welcome to Hack the Box console version 0.1 beta. So let's see, what can we do with this? I don't know, just type my hello. Recognize commands. First thing that comes out, command. So I don't know, I'm gonna try like random links commands. ID. Who am I? LS. Oh, LS works. ID. Oh, maybe because I added a space. Yeah, okay, so space changes it. ID, LS, I don't know, cat. So I don't know. It looks like we could run certain commands, but we could check for it for the most part once we actually put it on a decompiler. In my case, I'm using IDA, as you see right here. So check on IDA, go to main. So with main, it looks like fget 16 passing into an array of 16. So I guess fair. Then we get this certain specific function, so we just click on this. So this tells us what we can use. We could use ID, dir. So let's check dir. Oh, it just prints out home hack the box. String compare hof. We could try hof. We can enter name for the most part, and then we have ls for boxes, and then we have date, which uses the system command. So this seems interesting for me, system command, because we could run like, if we could somehow find the address of this and then like enter our own system commands, we could like I guess get some kind of shell with it. But for it looks like nothing much for the most part. But other than the system command, the other thing that stands out is this fgets, because if you look at this closely, oh no, not this fgets. If you look at it closely, we could pass in 48 bytes onto this 16 byte string. So that means we could get an easily buffer overflow. And let's just get this buffer overflow for the most part, and let's see how we could achieve this. So what we'll do is just do gdb and then hack the box console, how we usually do it for the videos. And then we want to create a pattern, so I'll just do pattern creates 48. Let's do 55. I don't know, pattern create 55. Have that. So now we want to do is just run it. How do we get access to this fgets? Oh, I guess if you just enter flag. Yeah, looks like we just enter flag. Okay, then this is where we type in this, and then we get 6 segmentation fault. Now we want to be able to, I guess, find the offset of our RSP, our stack pointer. So pattern offset of our $ RSP. We find it 24. So it takes 24. I guess to reach the stack pointer, it takes 24. So that's gonna be our offset. So now we know our offset for our stack pointer for the most part. So we know shell code is not going to be executed. And yeah, we know shell code is not going to be executed. I'll just have this. You can ignore this for now. I'll explain it later. So we know offset's 24. We just come up with our payload. So like I said before, shell code is not going to be needed. We'll most likely need to use ROP for the most part. And when ROP is basically using like certain gadgets that we find inside a binary to run code for the most part. That's how I understand it. So we know that offset's 24 to reach the stack pointer, and which that we're able to control the stack, the top of the stack for the most part. So we know that. What we can do, what I'm thinking is what do I know for the most part, we find the offset, and now we want to enter system, which with system we're able to, I guess, run certain commands, run certain system commands, or like, yeah. But I guess the problem with this, or the problem that I noticed right away, is that with system, how do we pass in our arguments? Because system takes in certain arguments, certain arguments. And I guess this is a question to ask ourselves: how do we pass in certain arguments inside this? Oh, I'm gonna delete that. So how do we pass in certain arguments? So to pass in certain arguments with system calls, all we need to do is be able to control RDI. And we could simply control our RDI is basically by simply using ROP. So with ROP, there's a bunch of like oh no. So with ROP, we're able to find like a certain like to find gadgets, and gadgets are usually just set in the instructions, are set of instructions. So yeah, so I guess to find this certain set of instructions, we could use a tool called ROP gadget, which we've been using in the past, or recently been using, and just run binary, the flag binary, and just and then the name of our binary that we want to do. So if we run this, for the most part, we get a bunch of gadgets that this certain binary contains, or certain assembly instructions that this binary contains at different addresses. Now, how do we find the one that we want to look for? We could just simply use grep, or just look at them all carefully, but I'll just use grep, and then we just look for the certain binary that we want. So what I want is just pop RDI. So now we find pop RDI. So this allows us to put input values into the RDI register. So now if we do notes.txt, nano notes.txt, now we have system. Now we have pop RDI. Now what we want to do next is to be able to, for the most part, put in our exact string value. And what we know for the most part is that our string values could be anywhere, but in our case, we need to input our string value, but we need to input a string value of bin.sh. So we could check what this binary currently has. And if we go right here and close id strings, no, this is not strings, sudo, I had it right here for a while. So strings, oh my god, I'm not supposed to go to views, open strings. So anyway, strings. So if you see, notice right here, there seems to be no string commands at all. No string commands at all, or no bin.sh in the strings. So we had to find a way to be able to create, I guess, our strings. But we do see the date command, which is used later on inside the binary. But I'll explain that later. So we want to find a way to be able to enter bin.sh into this specific file. Now, how will we do that? So if we were to check I guess the pseudocode itself, for the most part, we see that another time we get to input data into a certain part of an array is when you enter HOF, when you enter a Hall of Fame. When you register yourself for the Hall of Fame, you're able to input 10 bytes into this random piece of data. So what we can do is get this data's address, and this address we're gonna set it as bin.sh. So if you don't get what I'm trying to do is basically if we go to notes, so we get pop RDI and then we get the address of HOF, and the address of HOF we could enter 10 bytes, and those 10 bytes are going to be the bin sh, the bin sh. So what it's basically gonna do is we're gonna go to our offset. We're gonna set up RDI to load an address of end of file, and after that it's gonna run the system command. And this system command, system to pass in an argument, so it's gonna be system RDI. So this is basically what's going on, system RDI and plus the offset of 24. So this is basically what we're setting up for the most part, and RDI is gonna hold address, the value at address half, which is gonna equal to bin sh. So basically what we're doing is offset of 24 plus system bin sh, which is gonna get us a shell. It's not basically shellcode, but we're using the code already inside here to be able to get a shell, basically. And that's basically the whole point of this challenge, is using this. So in my solve script, nanosolve.py, we get pop RDI return address from using rob gadgets. Now the name address, we usually, so if I go back to the pseudocode, if I just click on this, you could probably do this on Ghidra. Ghidra is probably a little bit different, but if I just click on this bytes, it's gonna give me the address of what I'm looking for, and what I'm looking for is technically this. This is gonna point to the address right here. So this is where it's gonna hold all the bin sh data, and it starts with 4040B0. So that's what I have here, and then system call address. So how do we find the system call address? You can probably use Ghidra. In my case, I'm not using Ghidra, I'm using IDA. So how do you find it in IDA? I'll just show you guys right here. Or maybe I could do this quickly with Ghidra as well. So I'll probably load up Ghidra real quick and see if I could show you guys on Ghidra. So if I go to, I'm gonna try loading this up quick on Ghidra. So Ghidra run. It's just running up Ghidra. It's gonna maybe take a while. Hopefully it does not lag it. But anyway, I'll show you guys while this is loading up Ghidra. So with this 40138, I basically wait, let me just import file. Import file. This is gonna take a while. Home. My computer, my D drive. Oh no, wait, my computer. Oh, this is gonna be kind of tough. Wait, I think I might click recents. Yeah, it's gonna be kind of tough. Wait, cancel. Wait, what? I think if I just do this, and then if I go to downloads, yeah, if I go to downloads, oh my bad, I'm just like trying to set up the Ghidra side on my end, trying to set up Ghidra on my end. So if I have it right here, go to desktop, Pwn, HTB Console, and I can just drag and drop my this inside here, move inside there. Okay, and then while that's loading up, okay. Okay, so anyway, yeah, I'll show you guys how to find this. So system, what you want to do, just click on system for the most part. Click on it, click on system, and then over here you're probably oh, Oh wait, it's right here. Oh, let's just go pseudocode. Go to main. Go to the sub. Oh, oh, main. Main right here. Yeah, I'm just being dumb right now. A sub right here, and after that we just simply. Oh, I think I can just double click on this now. Oh wait, if I just click on this. Trying to do two things at the same time is not that fun. So now if I go to my idle view right here. Oh, main. Then if I go. Ooh, oh wait, we like to analyze. Yes, analyze it. This is for Ghidra, so analyze. This is just analyzing that. I'll show you guys how to find it right here. So if I go to main, and then we want to go inside this specific function call right here, and if we go where it runs the system command right here, for the most part, we see right here. If you guys go, the system command right here, the subroutine, like in this yellow box right here, we see that the sub where it's calling system, it says 401201. Might be too small for you guys, but it says plus 180. And then after that, all you do is just add those two together, and you'll get this specific value for the system call address, which is this. And I'll explain this date right here for right now, but let's just try finding it on Ghidra for you guys to show you. So if we go to functions, and then we go to entry, and then this is kind of rough. Is it still analyzing it? No. Right here, HTB Console. We go right here, fun. Then we want to go to system. So system. System, basically where you find the address right here. System. A lot easier on Ghidra. Or maybe because I'm not that I'm a lot more used to Ghidra, so that's why it's kind of easier for me to find it. But on IDA, I'm still kind of trying to get used to it. There's probably like an easier way to find it on IDA. If you guys know how to, just comment down below. Anyway, that's how we find it for Ghidra. And then this date, I just want to show you guys, you can pass in any string for the most part. So yeah, so if you go look at where the date variable is held at, so on IDA, the date it starts at 402107. So if you go right here, 4121, oh no, it's right here. Yeah, this date value, the entire date value right here is stored at 420101. So that's where I got this value at. So anyway, we build our payload right here, and what we do is first we start off by sending half, and we set our BNSH. We send it, and this is gonna set our BNSH value inside this name address. So now name address now holds BNSH, and after that we send in flag, and we pass in our payload, which is gonna cause a buffer overflow, and it's gonna run our entire payload, which is set up right here. And after that we're gonna get receive, and then we're gonna get interactive shell. So if I just do this, our payload, so okay, so if we just do Python 3 solve.py, we see that we have a shell, and if I write ls, we have whatever's inside. So now if I were to run it on our, I guess, remote host, so if I just uncomment this out, and then Python 3 solve.py, and then we're gonna get a connection, and then if I just type ls, we see that, and then we type flag.txt, we get the flag for this challenge. Now I guess a cool thing, I guess, to show you guys is let me just submit this flag in right here. Hopefully it accepts it. So let me submit this flag right here, solve this challenge. Oh my god, I might sign back in. Oh no, please don't make me sign in. I don't want to like end this video. Oh yeah, it is. Oh my god, I just docked myself. What does it matter? Challenges. Retire. And then yeah, it's gonna take a while right here. Oh my god. Pwn. HTB Console. and then submit flag. Submit right here. Put it at 5. Submit flag. So, well, it got accepted. So, yeah. So it got accepted. So, but what we can do is, in our case, let's say BinSH was like saved inside one of the strings for the most part. So, like, you know how I told you how I found a date string? If BinSH was somehow saved inside somewhere right here, what we technically do is just get the address of BinSH, but in our case, we have the address of where the actual date string is located. And if we just change this to date, it's gonna show us the date, the date. So if I just run this, it should show us the date. Oh, date. I have it named data. I bet. So if we just do this, date, and then boom, it shows us the date because it ran the system command of date. So that was pretty cool, I guess, to show you guys that if BinSH was inside this binary somewhere, we could just point to the address where the string BinSH is at, and and we could just put that in our system, which is on our system's function call, which is pretty cool to notice for you guys. But anyway, that was about it for this challenge. This was a pretty kind of long challenge for the most part, or like most of these Pwn challenges are getting kind of long because they're like a little bit more difficult than the easier Pwn challenges I was doing in the past. But anyway, that was about it. Hope you guys liked this video, and yep, peace.